I'm Ms. Jackson coming to you with another video.
Okay, we're going to talk about horizontal shifts, which are called phase shifts of tangent graphs. So back when we were drafting sine and cosine, and we looked at a sine graph, well, let's say y equals sine of x minus pi over 2, we knew that that was a shift to the right. And it's the same transformations in the tangent graphs, the cotangents, the cosecants, and the cosecant that we had for the sine and the cosine graphs. So those shifts are going to be the same. So looking at our tan function here, we have y equals tan of x minus pi over 2. We know that the x minus pi over 2 is a shift to the right pi over 2 units. All right, so that means the angles of our parent function, which is the y equals tan of x, will move to the right pi over 2 units. So the angles of the parent graph, which is y equals tan of x, will be shifted to the right. Okay? All right. All right, let's look at our parent graph, which is y equals tan of x. And for our parent graph, remember our asymptotes were negative pi over 2 and pi over 2. And again, these came from the unit circle. And remember, if I'm dividing by 0, if I put my sine over cosine and I divide by 0, it's undefined. So that means my tan values are undefined at negative pi over 2 and pi over 2. And these are asymptotes. All right. So we have our 0, we have a pi over 4. And then this side is negative pi over 4. In our graph, and then at pi over 4, remember the tan of pi over 4 is 1. The tan of negative pi over 4 is negative 1. So our graph did something like this. All right, so what we're going to do is look at the angles of our original tan graph. And then we're going to add the horizontal shift. And the horizontal shift should be adding pi over 2 because it's shifted to the right. So we're going to add pi over 2. So my asymptote was at negative pi over 2. But when we add the pi over 2 shift, my new angle is going to be 0. All right, then we have negative pi over 4. If we add pi over 2, and you can add these on a calculator, it'll make it just a little bit easier, so you don't have to worry about combining, getting the common denominator and all of that. If you want to do that, that's fine. So negative pi over 4 plus pi over 2 is pi over 4. Then you have 0. If you add the shift, it would be pi over 2. Then you have pi over 4 plus pi over 2. That gives you 3 pi over 4. And pi over 2 plus pi over 2 should be 2 pi over 2, which is just pi. All right, so these are our new angles: 0, pi over 4, pi over 2, 3 pi over 4, and pi. Okay, so for our new graph, y equals tan of x minus pi over 2, I created a little t-table so that we can actually plug these values in and get our tan of these angles. So we're going to start with 0. The tan of 0, because I'm substituting 0 in for x, of pi over 2 is the tan of, and 0 minus pi over 2 is negative pi over 2. So the tan of, remember, negative pi over 2 is negative 90 degrees. So that means that I would have, it would be undefined. So this would be my asymptote here. So I'm going to put A as Y for asymptote. All right, then I'm going to plug, substitute pi over 4 in for x. So I have tan of pi over 4 minus pi over 2 is equal to the tan of negative pi over 4. And remember, negative pi over 4 is the same thing as negative 45 degrees. So the tan of negative 45 degrees is equal to negative 1. All right, then I have the tan of pi over 2 minus pi over 2. Well, pi over 2 minus pi over 2 is 0. So the tan of 0 is equal to 0. All right, then we have the tan of 3 pi over 4 minus pi over 2, and that is the tan of pi over 4, because 3 pi over 4 minus pi over 2 is pi over 4. And the tan of pi over 4, remember pi over 4 is 45 degrees, so the tan of 45 degrees is equal to 1. And then I have the tan of pi minus pi over 2. Well, 1 pi minus pi over 2 is just pi over 2. And remember, the tan of pi over 2, if you look at the unit circle, that is undefined. So since it's undefined, it will be an asymptote there. Okay, so now I can plot my points. So I have an asymptote at 0. So this is just making a dotted line over the y-axis here. This is where 0 is here. And then you have an asymptote at pi. I'm just going to go ahead and draw in my asymptotes here. All right, then add pi over 4. You're at negative 1. So negative 1 is here. So you right here. Add pi over 2. I should be at 0. The y value is 0. And add 3 pi over 4. I'm at positive 1. All right, so I'm right here. All right, so my graph does something like this. It goes through these 3 points that you get close to the asymptotes, but don't cross them. All right, and that's pretty much all I need to do. So now you have some practice problems. You have 5 practice problems that I want you to actually go through and graph them just like I did this one. You can refer back to the video if you didn't take good notes, but I need for you to take good notes.